All right, let's do a little prime factorization. Prime factorization is going to be on your test because it's showing up in the next chapter. It's going to be really important for us to help understand fractions completely. So let's give this a go. If you run into a question on your test that you are not quite sure about, and you're not sure what times what equals 39, what times what equals 52, my recommendation is to do some division to test it out. If you're not sure, check if it's an even or an odd number. 39 is odd, so I would always check and see if odd numbers are divisible by 3. They're not always, but sometimes they are, and that'll help you figure things out. 3 goes into 3 one time. If I do some subtraction, I get a 9, and I know that 3 goes into 9 3 times. So 3 divides into 39 perfectly and comes out with an answer of 13. So 39, I know, can be split into 2 parts, can be split into 3 times 13. Now we are looking for prime factorization, so I'd go through and check and make sure everything is prime. 3 checks out, 3 is prime because you can only do 1 times 3, and 13 actually checks out also because that's prime too. You can only do 1 times 13. So on your test, I'm asking for 2 things. I'm asking for an expression and an expression with exponents. The expression that I want you to be writing down is exactly what you just figured out, that 39 is 3 times 13. And the expression with exponents, some people really like to put the exponents, even though they're not necessary in this case. The only time when the exponents are unnecessary is when they are powers of 1. I would accept powers of 1 like I just wrote right now, or I would also accept just 3 times 13. Even though it doesn't have any exponents written on it, I would accept that in the second line. Okay, so let's do another one. 24. 24 is an even number, so we know it's going to divide by 2. But I know off the top of my head that 3 times 8 is 24, so I'm going to start there. If you wanted to use anything else like 6 times 4 or 12 times 2, you can. You'll get the same answer in the end. Going through my list, 3 checks off, that's prime, but 8 is not prime yet, so I need to break it down. Be sure, though, that you remember to bring your prime numbers down to the next line. That's a really important step that I want you to remember. 8 can be broken down into 4 times 2. All right, so let's go through and check. 3, yep, that's still prime. 4 is not prime yet, but 2 is. So it looks like we're only focusing on this 4 right here. So bringing it down, we're going to have the 3. And then 4 can be broken down into 2 times 2. And we do have to remember to bring this last 2 down. If you forget him, then you're not going to get 24. You can always double check your answer. 3 times 2 is 6. And then 6 times 2 is 12, and 12 times 2 is 24. So we do get our original answer, so it checks out. The expression is going to be 3 times 2 times 2 times 2. And the expression with exponents would be 3 times 2 to the power of 3, because there are 3 2's being multiplied and 1 3. The other answer that I would accept for this is 3 to the power 1 times 2 to the power 3. But this one is an optional one, and that's up to you. 60 is a little bit bigger. It takes a little bit more work going through. I would like to break 60 down into 6 times 10, because I know that when numbers have a 0 at the end, you can always multiply 10 as a factor. 6 and 10, neither one of those are prime, so we're going to have to go through a couple steps. 6 is 2 times 3, and 10, I can get that by doing 2 times 5. So going through my list, 2 is prime, 3 is prime, 2 is prime, and 5 is prime. So we already have it. This right here would be your expression. 2 times 3 times 2 times 5. And then your expression with exponents. 2 ways that I would accept it. I would accept it with 2 to the power 2 times 3 to the power 1 times 5 to the power 1, Or again, those ones are optional. I would accept 2 to the power 2 times 3 times 5. 100. Ooh, I said that I like doing tens with numbers that have zeros at the end, so I'm going to continue with that pattern. And 100 can be 10 times 10. 10 breaks down into 5 times 2. And then we would have another one, so we'd have another 5 times 2. Checking through everything, 5s and 2s are all prime, so 5, 2, 5, 2, all prime. And using exponents, I see 2 of each number, so we would have one possible answer, 5 to the power 2 times 2 to the power 2. Now, the number 17, I like this one. It's really interesting because if I ask you for a prime factorization of a number like 17, 17 is odd. So if we check our division and we do 17 divided by 3, 3 only goes in 5 times, and there is a remainder. So 3 doesn't divide perfectly. We can go through, and if you check in your head, 17 divided by 5, that doesn't divide perfectly. 17 divided by 7, that doesn't divide perfectly. There's a remainder. Anything that you are going to try is going to give you a remainder. So what that means, and what you might have already known, is that 17 is already prime. And if the number is already prime, you do need to know what to do. Some people will put down 1 times 17, but that's actually not a prime factorization because the number 1 is not a prime number. So if you come across a number that is already prime and you can't factor it into its pieces, your expression would be the number itself. Your expression would just be the number 17 with no multiplication. Using exponents, 2 answers that I would accept 17 to the power of 1 or just the number 17 again. Okay, so if the number's already prime, don't use the 1 because 1 isn't prime and that makes it not a prime factorization anymore. All right, last one, the number 28. I know that 28 is 7 times 4. Checking 7, yep, that's prime, but 4 is not prime, so let's do 7 times 2 times 2. And that gives us our expression, 7 times 2 times 2. And then our expression using exponents would be 7 times 2 to the power 2. Or, of course, I would accept 7 to the power 1 times 2 to the power 2. Okay. I hope this helps you with prime factorization if you were struggling with it. And if you need more practice, you can just do the numbers from 1 to 20 or from 20 to 30. You don't need me to give you specific problems, just pick some numbers. Generally, you can stay in the range of 2-digit numbers. 2-digit numbers are really reasonable for me to ask you on your test or reasonable for us to be doing in Chapter 3. So, I wish you luck with prime factorization.